the algebraic fraction. And in our last class, we have a look at what a fraction is. But today we're going to proceed by looking at the algebraic fraction. And when we talk about the algebraic fraction, here we are considering when we have both letters and numbers. You know, for the word algebra, this is when you have numbers and you have letters. It forms an algebra. And let's have a quick review of what fraction is. Fraction is when you are dividing a numerator with a denominator. And recall that we have three forms of fraction. Here we have the proper fraction. Okay. Also, we have so here we have the proper fraction. We have the improper fraction, and also we have the mixed fraction. So here we have the improper, and here we have the mixed. So these are the three forms of fraction that we have. These are the three basic forms of fraction we have. So now we are looking at a situation whereby we have the algebraic fraction, that is the combination of both the number and the letters. You can check my previous video to see how I solved some questions regarding fraction. Now, let's have a look at our first example. And before I proceed, let me just give an highlight of what proper fraction is. In the proper fraction is when you have the numerator less than the denominator. This is a typical example of how the proper fraction looks like. But for the improper fraction, it's going to be the reverse. The numerator will always be less than the denominator. And for the mixed fraction, it is the improper fraction that leads to the mixed fraction, where you can have one whole number 1/2. So you have something like this. This is a typical example of mixed fraction. Now, we want to use the basic knowledge of what we did in the last class to extend it to the algebraic fraction. Now, for the algebraic fraction, this is when you have, for example, you're having 2x over 3 plus, okay, 3x over 3. Remember, in the last video I uploaded, I told you this rule. In this case, we are having the same denominator. And anytime you're having the same denominator, it is very easy. Okay, the LCM is just going to be the denominator. Just repeat the same denominator, which is going to be 3. And looking at the numerator, add the numerators together. So when you have two fractions with the same denominator, what you just have to do is write down the denominator and add up the numbers at the top. So here we have 2x plus 3x. 2x plus 3x. So 2x plus 3x can give you 5x divided by 3. So what I'm trying to say here is that when you have two fractions with the same denominator, just write out the denominator and you can add up the numerator. This is rule number 1, which makes it very easy. The same thing can be done when you have subtraction. For example, we have 4x over 5 minus 2x over 5. Okay? Here we have 4x over 5. You're having the same denominator of 5. So you can write out the same denominator of 5. And what are you going to do? Look at the numerators. Just, which is 4x minus 2x. And here we can have 2x over 5. So this is the general rule for the basic algebraic fraction. This is the general rule. So now for the rule number 1 is when we have the same denominator, what are you going to do? Just write out the denominator and do what? You proceed by adding up the numerator. Now let's look at this second case. And what is the second case? The second case is when you don't have the same denominator, what are you going to do? When you don't have the same denominator, what are you going to do? For example, we have 2x over 3 plus 3x over 4. We have 2x over 3 plus 3x over 4. If you look at this rule number 2, the denominators are not the same. We don't have the same denominator in this case. The denominators are not the same. Then what are you going to do? The rule says that the denominator, multiply them together. You multiply them together. 3 multiplied by 4, we have 12. We have 12. Okay? Multiplying the denominators together, and you're going to cross multiply. And how do you do that? Look at this. Let this multiply this, which is 4 multiplied by 2x. You can put it in parentheses. And also let 3 go with this. So what you are just going to do is to cross. The numerator here is multiplying the denominator on the other side, and the denominator on this side is multiplying the numerator on this side. So this is the method to use. So here we have 3 multiplying 3x. Okay? Now, 4 multiplying 2x, we have 8x. Plus 3 multiplying 3x, we have 9x. Divided by the denominator. And here we can have 8x plus 9x, which is 17x. Divided by 12. So you can see this. So this looks pretty much easy to work with. So if you follow the rules, you can work with any questions regarding this kind of fraction. Okay. Now let's look at some other robust rule that we can have. And the question here I have for you now is, if you have something like this, if you have 2y divided by 3, okay, or let me just put something else. 2y divided by 5 minus y divided by 3. How can we do this? Using the same approach I used here, how can you work with this? Okay, now if you have 2y over 5 minus y over 3, can you use the same approach, and let's see how you can do this? Okay, let's see in the comment. To do this, it's pretty much easy to work with. And how can we do that? Using the same approach. The denominators are not the same. You can multiply them together. Okay, so you have the LCM to be 5 times 3, which is 15. And the next thing to do is to apply this rule. So you want to apply this rule. Your 5 multiplying y. So here we have 5 multiplying y, okay, minus we have 3 multiplying 2y. We have 3 multiplying 2y. 5 multiplied by y gives 5y, minus 3 multiplied by 2y gives 6y, divided by the common denominator, which is 15. And here we have 5y minus 6y, which gives negative y over 15. So this is what we have using this rule. Now, having known this, we can proceed by looking at some other robust approach that we can use, whereby we have from the denominator combination of two values, okay? And let's quickly have a look at that. So we are going to use the same approach we've used just to do this. And what is the approach? For example, we have 2x minus 1 over 2 plus x plus 2 over 2. This is what we have. This is now like a compound problem. Why? Because we're having 2x minus 1 over 2 plus x plus 2 over 2. If you look at this problem, how do we go with this problem? It's just the same approach like I explained earlier. Here we're having the same denominator in this case. We have the same denominator. So like I told you, if you have the same denominator, what you just have to do is repeat the denominator. And the denominator is what? 2. Just write out the denominators again, okay? And once they have the same denominator, here, you just have to rewrite the numerator, which is 2x minus 1. You can put it in parentheses to be safe that you've done the first part, plus, which is the sign and the middle. So write out this, which is x plus 2. Now, what else? Let's bring them out. Here we have 2x minus 1 plus x plus 2 over 2. The next thing we have to do is to collect the like terms. And what are the like terms? The algebraic terms are going to be different, and also the other term is going to be different. And the algebraic term here is, let's collect the like term. We have 2x and we have plus x. So take them together, which is 2x plus x. And here we have negative 1 and 2. Negative 1 plus 2 over 2. So 2x plus x, don't forget when we have x, it's like you are having the coefficient of x to be 1. So it is like saying 2x plus 1x, and that gives what? 3x. Minus 1 plus 2, that gives plus 1 over 2. So this is how to deal with a little bit complicated algebraic terms. Okay, this is how to deal with it. For today, lastly, I'm going to have a look at something different, and we'll continue next week. Let's have a look at something quite different from this. And what we have is, when we have the denominators to be different, let me just put minus 2. Here we have 2, we have 3. And let's put the negative sign here. So how do we go with this? Now we're having two fractions with different denominators. The denominators are quite different from one another. Then how do we do this? Now to do this, like I told you, if you have different denominators, just multiply out the denominators. 2 and 3, which gives 6. After multiplying up the denominator, you apply this rule, that's cross multiply. You do what? You cross multiply. And how do we cross multiply? It's very easy to do. Here we have 3 multiplying this, and we have 2 multiplying this. So 3, you can put this in brackets or parentheses, multiplying the numerator here, which is 2x minus 2. Now look at the sign, which is the negative sign, minus, here we have 2 multiplying the numerator, 2. The numerator is x plus 2. Okay? Next is to bring out the parentheses. And how do we bring out the parentheses here? 3 multiplying 2x. You are just multiplying out the coefficients. 3 multiplying 2x gives 6x. So to distribute, you distribute 3 also to negative 2. 3 multiplying negative 2 gives negative 6. Minus 2 multiplying x. These 2, we have negative 4. And we still have the common denominator of 6. The next thing for us to do is to collect the like terms. So you take the x separate and the other value separate. So here we have 6x also with negative 2x separate. And here we have negative 6 and negative 4 separate, divided by 6. Now we've separated the algebraic terms and we've separated the other terms. And the next thing to do from here is 6x minus 2x, which gives 4x. Negative 6, negative 4. This gives negative 10 over 6. If you have a look at this, you can decide to stop. But if you want to simplify further, okay, what do you think you can do? Can anybody put this in the comment section? Any suggestion? What do you think we can do? Are we going to just leave it this way or factorize? Yes, we are going to factorize. You can look at what is similar between 4 and 10. Here, we can proceed by saying 2 is common. Okay? Just bring it out. We have 2x minus 5 over 6. And finally, you can say that 2 cancel out 1, 2 here, 3. So finally, we can have 2x minus 5 over 3. This is the simplified form of this problem. This is simplified form of this problem. We have 2x minus 5 over 3. And we can look at a situation whereby we have an equation, because in this example, what we have is just an algebraic expression. Now, let's have a look. When we have an equation, how do you think you can do this? Now, let me clean this up. So when we have an equation, I'm going to throw that as a problem, and I would like you to try it. That is, if you have something like 3x minus 1 over 3 plus 2x plus 5 over 2 equals to 1. I want you to solve for x. Put the answer in the comment section. Let's see if you can do this. Okay, use the same approach we've used. Solve for x and put the answer in the comment section. I'll be back. So I'm going to give some time for you to do this. And if you can do this, that would be great. Okay, I'm going to give some time for you to do this. Just put the answer in the comment section, please. Just put the answer in the comment section. Using the same approach we've used, we have 5 minutes more to do this. After 5 minutes, I'm going to do it. Okay, just do this and let's see. Yeah, we have here, we have to solve the left-hand side separately. Okay, we solve the left-hand side separately, and also we cross multiply with the right-hand side. And to do this, okay, they are having different denominators. You multiply them together, which is 6. And you do it this way using this method. So we have 2 multiplying the numerator on this side, plus we have 3 multiplying the numerator on the other side, which is 2x plus 5 equal 1. Now let's solve the numerator first. By solving this numerator, we have 2 times 3x, which is this multiplying this, we have 6x. 2 multiplying -1, we have -2. 3 multiplying 2x, we have 6x. 3 multiplying 5, we have 15. Okay? Dividing this by the common denominator of 6 equals to 1. And the next thing to do is to add up the common terms, which is 6x and 6x, which is 12x. -2 and plus 15 gives plus 13 over 6 equals to 1. It's the same thing as saying 1 over 1. And the next thing to do is to cross multiply as usual. Then we have 6 times 1, 1 times this. So if you use 1 to multiply this, we have the same value back, which is 12x plus 13 equals to 6. Because 6 times 1 is still 6. Now, solving for x, you can watch my videos here where I talked about how to solve for x when you have something like this. Add negative 13 to both sides. And here we have 12x. This is going to cancel out. 6 minus 13, we have negative 7. And to solve for x, here, the next thing you do is to what? Divide both sides by the coefficient of x, which is 12 and 12. And finally, 12 cancel out 12, we have x equal negative 7 over 12. And this is going to be the end of our live section for this week. Join me again next week, Sunday. Take care of yourself. Bye.